Hi guys, so we're going to look today at the last method for solving quadratics and also look at a couple more applications of it. And that method is completing the square. So you probably saw this in Algebra 1, so it may be review, hopefully it is. But completing the square actually has two really important uses for us. We can use it as a method for solving quadratics, but we also can use it to take a quadratic from standard form and easily write it in vertex form. So before we do that, what we're going to do is we're going to review what a perfect square trinomial is. So a perfect square trinomial, we looked at this when we were factoring, is something in the form of a squared, that's a typo, plus 2ab plus b squared. So something in that form can factor into a plus b squared or a minus b squared, basically whatever this sign is. So an example of this would be x squared plus 2x plus 1. That would factor into x plus 1 squared. Another example would be x squared plus, let's not do 3x, plus 6x plus 9. That's going to factor into x plus 3 squared. All right, so again, it's kind of that we talked about if you're going from the multiplying to actually multiplying it out, it's that square, double, and square shortcut. That's your perfect square trinomial. Now, it's important to notice this is not the same thing as a difference of squares. Difference of squares is where you start with a binomial and you factor it into your difference of squares. So that's a difference of squares. We're talking about a perfect square trinomial where we start with the trinomial and we end up in the factored form where we have that same binomial that's squared. All right, so what we're going to do to start is we're just going to write, let me go ahead and rewrite that as squared. That's how it should be. What we're going to do is we are going to find what term we need to put in here in order to create this perfect square trinomial. So we need to follow that format. Okay, that format is it's a squared plus 2ab plus b squared. So in this case, let's see what pieces we have. Okay, a squared is my x squared. So if a squared is my x squared, a is x. All right, let's look at this middle term. 8x is the 2ab term. So if 8x is 2ab, I know what a is. A is x, so I'm going to replace that. Well, then if I want to know what b is, to solve for b, to get b by itself, I would divide by 2x. So b is 4. Now what goes in the trinomial, though, is not b. What goes in the trinomial is b squared. B squared is 16. So x squared plus 8x plus 16 is a perfect square trinomial. It would factor into x plus 4 squared because it follows that a squared plus 2ab plus b squared format. Now there is a little shortcut whenever you have this form, and we're going to look at that once we actually do completing the square. But let's find some with question marks in different places. All right, let's try this one. So again, we want it in the form of a squared plus 2ab plus b squared. Well, if 25a to the 6th is a squared, just regular old a, okay, the square root of that term would be 5a cubed. The b would just be 2b. It's the square root of both of those terms. So the middle term is 2 times a times b. So that gives me 10 times 2 is 20, a cubed b. So that means that 25a to the 6th plus 20a cubed b plus 4b squared would factor into a perfect square trinomial where you just have that binomial squared. All right, looking at the next one. Okay, so again, my b squared is 49. That means that b is 7. My 2ab is negative 70x. Well, I know what b is. B is 7. So 14a is equal to negative 70x. We're trying to figure out what a is. So I would divide by 14, and I get negative 5x. A is negative 5x. This term here is the a squared, so I would square the number and the x, and I would get 25x squared. All right, then looking at the last one, again, let's find a. So the cube root of that is 3x. Sorry, square root. No, I said cube root. My 2ab is negative 2x. All right, the a is 3x, so I'm going to replace that. That's going to become 2 times 3x. That's 6x times b. So to solve for b, I would divide So I get a negative 1/3. But again, what goes here is b squared. So when I square that, when you square a fraction, you square the top and the bottom. So that would be 1/9. All right, so now what we're going to do is look at how completing the square actually helps us. So we've got two really main causes we use this for. One is to take standard form and write it into vertex form. So what we're going to do here, if you have an a value of 1, okay, though there's no number in front of your x squared, it's actually pretty simple. So what we're going to do is we're going to rewrite this. We're going to do x squared minus 8x, and then we're going to leave a blank. Then I'm going to move this 4, and I'm going to subtract a blank. The reason I'm doing that is because I'm going to add some value here to where it's going to create a perfect square trinomial. Whatever I add there, though, I also need to subtract so that I still have the same equation. I can't just go and add 8 to this equation. It's going to make it a new function. So I need to keep this the same equation. So if I add something, I need to subtract something. To figure out what that number is, we can use that same pattern we just did. But because what we're dealing with is an a value of 1, and we're trying to find this last term, what's going to happen, and you'll see this if you work these out, every single time, you take the b value, you divide it by 2, and you square it. So I would do negative 8 divided by 2, that's 4. 4 squared is 16. That creates my perfect square trinomial in the form of x minus 4 squared. Now, again, if I added 16 to this equation, I also have to subtract 16 to this equation, because again, I'm trying to keep it the same. 4 minus 16, negative 12. So this is the same equation, just in vertex form. That makes it easy to see the vertex, makes it easy to see your transformations as well. All right, let's try another one. So x squared minus 6x plus blank minus 2 minus blank. The number that goes in the blank, I take the b value, I divide it by 2, and I square it. If I add 9 to the equation, I also subtract 9 from the equation. That perfect square trinomial would be x minus 3 squared minus 11. And now we're in vertex form. So what you'll notice about this binomial, how it relates to this trinomial, is that it always ends up to where this number is half of that middle number, and the sign's going to be the same. So that's the way it'll always factor into. All right, now let's look at what happens when the a value is not 1. So when the a value is not 1, we're going to do a similar process, but we have an additional step at the beginning. Whatever that a value is, we need to factor it out. Now we can't just get rid of it, because again, we're trying to rewrite this equation in vertex form. We need to have that stretch there, because that's a different equation. So I'm going to take that 2 and factor it out of those first 2 terms only. So I'm going to do 2x squared minus 12x, and I'm still going to leave my blank. And I'm still going to subtract a blank. All right, so remember, if I were to take this and multiply it, it would be the same thing that I already have. I just factored it out of just the first 2 terms. Number that goes in the blank, middle term, divided by 2, squared. So that's going to be 6 squared is 36. Where we need to be careful, though, is I haven't actually added 36 to this equation. I've actually added 2 times 36 to this equation, because that 36 is inside those parentheses, which means I've really added 72 to this equation. So if I've added 72 to this equation, I also need to subtract 72 from this equation. Now that 2 stays on the outside, I can factor this. And I'm in vertex form. All right, one more, very similar. We need to factor out what's in front of the a. This time it's just a negative, though. All right, so to rewrite this, that negative would get factored out. This now becomes minus 5x. And that 3 is going to be on the outside. All right, it's a minus because if I went and multiplied it back, I would get this. All right, so to figure out what number is in the blank, take the middle, divide it by 2, and square it. So that's 5 divided by 2 squared. When you square a fraction, you square the top and the bottom. So that's 25 over 4. Now this one, again, a little tricky. I didn't actually add 25 over 4 to this equation. I actually added a negative 25 over 4 to this equation, which means to keep it balanced, I would need to subtract a negative 25 over 4. Another way to write that is add 25 over 4. So now that negative is still there, because again, it has that reflection. This would factor into x minus 5 over 2 squared. I can get a common denominator to add those together. That's going to give me 37 over 4. And now I'm in vertex form. All right, so the last thing we'll use completing the square for is to actually solve quadratics. So this is a method, again, this is one kind of like quadratic formula. You can't always use it. Personally, I think it's the easiest method when your a value is 1 and your b value is even. Or if you can divide by the a value to get an a value of 1 and a b value that's even. That's why I think completing the square is actually a lot faster than quadratic formula. It requires you to do less simplifying and just, I think, goes a little bit faster. So what we do here, process is very similar. We kind of do one thing a little bit different though. Because we're eventually trying to get x by itself, instead of just moving this number kind of away, I'm going to actually move that number to the other side. Now, just like I did with writing in vertex form, I'm going to leave a blank. And I'm going to add that number that's going to create that perfect square trinomial. But what's different now, instead of subtracting it from the same side, I'm going to add it to the other side. Now it's the same thing if you think about it. If I were to subtract 2 over here, eventually if I moved it to the other side, I'd be adding 2. I'm still trying to keep this equation balanced. So let's find what that number is. Middle number divided by 2 squared, that's 4. Well, if I add 4 to the right side of the equation, I have to add 4 to the left side of the equation. It's keeping this the exact same equation as it was, keeping it balanced. So now this is a perfect square trinomial that factors. And now we're solving using that same square root method that we did last class. So I would square root both sides. To get x by itself, I would add 2. And since these are rational numbers, I can go ahead and actually solve these and actually figure out what this is. So this would be 2 plus 3 and 2 minus 3. Now, when a is not 1 in this case, this is actually a little bit easier than if I'm trying to get this into vertex form. So since this is an equation and it actually equals 0, if you do the same thing to every part of an equation, then it's still the same thing. So instead of just factoring out that 2, you can do that, but it's going to make your life a lot harder because you're going to have to get rid of that 2 eventually to solve it. What you do when you're solving is you go ahead and divide every term by whatever that a value is. Because if you divide everything by that number, you still have the same equation. So I'm going to divide everything by 2, every single term. Well, 0 divided by 2 is 0. Then I have x squared minus 2x minus 4. And now I can solve this by completing the square. So again, I'm going to add 4 to the other side and leave a blank. I'm going to leave a blank on the right side. To figure out the number that goes in the blank, I'm going to take the b value, I'm going to divide it by 2, and I'm going to square it. That gives me 1. If I add 1 to one side, I add 1 to the other. So now I get 5 equals x minus 1 squared. Solve by square roots. So plus or minus the square root of 5 equals x minus 1. So x equals 1 plus or minus the square root of 5. All right, let's look at one last one. This one's going to get a little ugly on the fractions, I'll warn you now. But again, a value here is not 1. So I have to divide everything by that a value. So that's 0 equals x squared minus 3x plus 7 over 3. So already looking a little ugly. So let's move that 7 over 3 to the other side and leave a blank. To figure out the number that goes in the blank, b value divided by 2 squared. 3 over 2 squared is 9 over 4. This is going to factor into x minus 3 over 2 squared. Get a common denominator over here. So that's going to be 12. So I'd multiply by 3. Multiply the right fraction by 4. That's negative 28 over 12. That gives me a negative 1 over 12. Square root both sides. So when you square root a fraction, you're square rooting the top and the bottom. So the square root of 1 is just 1. So this is just going to be the square root. So we're 1 over the square root of 12. It was a negative under the square root, so that's going to become an I. And it is plus or minus. All right, the square root of 12 can simplify. I'm going to simplify that as 2 root 3. I'm going to add that 3 over 2 to the other side. And then there's only one last thing I need to do, and that is rationalize. So I need to get that square root out of the bottom. So the way I do that is I multiply by root 3 on the top and bottom. So that gives me 3 over 2 plus or minus root 3 over 2 times root 3 times root 3. So root 3 times root 3 is 3. 3 times 2 is 6. So this is a case where, like I said, if that b value is not an even number, it can be a little bit messier. So when that b value is odd, it's a little bit harder and a little bit longer than just using quadratic formula. So this actually might be one that might be a little bit faster if you'd use quadratic formula on. All right, so that is the last method for solving quadratics. And again, complete the square is going to come back later on. When you guys get to conics and pre-cal, you'll have to use it again to write things in a different form. So don't just blow it off as, hey, this is just another method I don't really need. It is going to keep coming back up, so make sure you guys get some practice on it.